so like, yeah, it was crazy. Like meetup.com, and there was this thing that used to be more popular called Let's Lunch. And so I literally would have like a lunch with a rando person that I matched with, almost like Tinder for lunch with business people.
They edit that
And then
together.
I guess there's no swiping, but I don't know. There's some kind of like interests that it matches you on. And then yeah, I also went to all these meetups, and they were at different times, and I just met a shitload of people, you know, that way. So yeah, I think that.
Check.
Like repeat people.
Check.
I just gotta switch. There's two mics. There's like the
Check.
internet mic and the real mic. Yeah. This shit. This is when I have my solo, then I can like really hit it. Yeah. A dancing mic. Yeah,
Check.
I know. Me too. That's, when I see these mics, I always think about some stage performance. I don't remember it. Oh, she's got. Oh, is that right? She was the first to do this. I don't know a lot about music. No, I'm just lame. This is why I'm giving an engineering talk and not like a cooler talk.
We'll start on the wide. And I don't think that need any no dissolves at all. Oh, really? Yeah, I don't think we need any for that.
Sorry, I don't want to block you.
That's okay. Sorry, just need to get down.
Yeah.
Sorry.
And so, can you sit right there? Yeah, sit there. Perfect. Great. Can I get the
Oh,
big
it's
mic?
you. Hi.
Is it hot?
Yes.
Yeah. Oh, we need someone to sit. Take that spot. You want to sit? Or where are you going to move? Maya or. Right here, folks. It's good to have them filled. Does someone want to move in from the steps? Do you want to sit over here? We'd love to get. It's not a magic show. We're not going to pull people out of the audience and hypnotize you. Yeah. Look good on video. You're going to look great on video. That's perfect. That's good. How you doing tonight? I see a lot of familiar faces. That's cool. How many folks here, this is your first time at a What's Now? All right, good, about half. Oh, is it me?
That's me. Sorry.
Standing next to that one. I'm Peter Maloof. I'm the director of the New York Applied Innovation Exchange. That's part of this floor that you're sitting on. Here at Capgemini, this is our innovation floor. So we do strategy and new product development, also work with startups and VCs. One of the best things about this job, though, is being able to host this kind of event. So we've had a long-standing relationship with Pete Leiden and reInvent. And when I took this job, I think this was one of the highlights for me because I was getting some fashion tips from Pete, who tonight had a little bit more mellow shirt. I thought for sure with spring you would go hard, and then I would be able to one-up you. And all of the guests that we've had here have been terrific, and tonight is another great program. Nick is doing a repeat. We've had him out on the West Coast, and he's a terrific speaker. We've got a great program, and so we're really looking forward to it. Thank you all for coming tonight. Stick around afterwards. I think we'll be able to finish off the food and the drinks after that, and still give time to interact. So with that, Pete, I'll turn it over to you. Thanks, everyone.
Thank you, Pete, and thank you, Capgemini, and the whole team here. And thank all of you, particularly those who have come before. I know you've borne with us here. We've gone through some changes in this series. For example, we're now going more quarterly as opposed to monthly, so some of you have hung with us over the last few months here. We've also got a new registration system that we're kind of working the glitches out of, but you've been working with that. We've got a new logo. We've got this live stream is also going to be going to a different place, although you can still get it off the reInvent site, but this is going to a Capgemini environment. So thank you for kind of evolving and innovating as we kind of innovate this thing and move it into this year and the next year possibly too. So that's, thanks for that. Now the rest of the evening is relatively similar to things we've done before. And for the new folks, what that's going to be is we're going to have a little presentation here. Now, one way to get your head in general into what we're doing tonight is to kind of pull back and think about the big story here. And when you think about literally the last 40 years, from the 80 to now we're getting close to 2020, folks, there's been a kind of the digital revolution story. I mean, we started in the 80s with the kind of, hey, we're monkeying with these big PCs, and then the 90s we're connecting them up with basically through the internet. And then kind of the last couple decades has been this incredible transformation as this new digital infrastructure and software essentially has kind of helped reinvent the world. Capgemini itself, in fact, spends a lot of their business like helping businesses kind of digital transformation. It's still much to come, and there's still much going on there. But essentially, that story has been that story. When it comes, it's been essentially how do computers manipulate immaterial things? How do we actually take information or data or media that's text or audio or video, and how does that actually get reinvented in a very fundamental way? So it's been a kind of an immaterial things story, and it's been really driven by software in many respects. When you think about the last 40 years about hardware, how we make physical things, it's a different story. Now, there's actually been quite an interesting revolution, but I would say it's more about globalization. If you take those same 40 years, we used to make things kind of the old 20th century way here in the good old USA, let's say, as far up into the 70s. By the 80s, Japan's kind of doing more of this. In the 90s, we start China and the developing world. So there's been essentially a globalization restructuring of how we make things. But it's been mostly innovation around supply chain and kind of how we move things. But it hasn't been fundamentally different of how the machines actually make things. But that might change. And that's what we're going to talk about tonight, is we're going to actually, our speaker tonight, our featured speaker tonight, has got an idea that I think is a very powerful idea that we're going to actually start to fundamentally shift the way we make physical things. And many of the things we learned through software development and the refinement of how software works, interoperability and all kinds of things, are going to start increasingly applied to hardware. And so there's going to be a transformation in the making of things which is yet to come. Now, the guy to tell that story, which is going to be a fascinating story, is Nick Pinkston off here to the side. He'll be here in a second. Nick's a really great guy to tell this story because he kind of came of age at the kind of the second half of that digital revolution. So he was living and breathing the software kind of digital revolution that a lot of us had to kind of start from square one on. And so that he just kind of took for granted. He then also grew up in Pittsburgh, and he was kind of part of the whole early pioneering maker movement, particularly in Pittsburgh. And his first company as a young person, Cloud Fab, was essentially trying to make manufacturing as a service through kind of connecting it through APIs. That was his first company. I got to know him when he was actually running his second company, the founder of the second company, Plethora, which is in San Francisco. And Plethora was trying to figure out, okay, how do you take like a souped up CAD or computer-aided design to kind of essentially quickly manufacture specialized parts in a kind of an on-demand automated factory, essentially. So it's trying to take some software innovations and essentially apply it to actually accelerating the making of kind of things. Now he has turned over, that was a very successful company, it still is a very successful company, venture-backed, it's been scaling. He's turned over the reins as CEO to a new person just this year, and he's on to his third company, which he can't really talk about, but it's actually in the space that he's going to be generally talking about here. So we're going to learn a lot about the generic kind of space he thinks is ripe for reinvention, but he can't get too deep into the specifics on that. So Nick is a really remarkable guy. For one thing, he's young, and he's a relatively young guy. He was essentially, Forbes named him in there among their 30 under 30 in the manufacturing industry space in 2016. He's, like I said, he's on his third company now, in his early 30s here. And the thing that really makes him even more interesting to me is he's kind of a Renaissance guy. And he's got big ideas on economic theory and economic policy, and he's getting involved in politics and all kinds of stuff. And so we might, by the end, actually chat a little bit about that as well, too. So what we're going to do is he's going to come up here, give us big ideas on the future of tools, a presentation. I'll come back up and interview him for a little bit and kind of roll into a conversation with all you. And with that, I think let's welcome Nick.
Awesome. Thanks so much, Peter. Awesome.
Did you turn on your?
I did. Can you guys hear me?
Yeah.
No? This is on. Can you hear me now? Okay, lovely. Okay.
Oh, yeah, I'll bring that up.
Oh yeah, you got to do the whole AV
that?
stuff? No, we're good. We're good. Okay, awesome. Well, thanks so much for having me out, guys. I really appreciate it. And this is not just a repeat talk. This is like almost like 60% new material, I would say. Like the businesses are the same, but there's a lot of things that are actually going on in the world. And my thinking has even evolved since, I guess, 2 years ago when we did this. So to sort of repeat a little bit of what Peter talked about. So, there's actually, these are the first 2 companies I made. But, one of the first things was Hack Pittsburgh. So I actually came to New York probably 12 years ago to Brooklyn to MIC Resistor. Anyone ever go to Resistor? So it is like basically one of the ground zero of where a lot of the maker movement came, and a lot of the revolutions in manufacturing started out as like little companies. I remember being in Brooklyn with like Brie Pettis, Adam, and Zach putting together MakerBot 3D printers, forever ago. It was amazing. So all that started here, which is pretty cool. So Hack Pittsburgh was, I came back to Pittsburgh, Pennsylvania, and said, well, let me start one of these things too, and that's still there actually. And we have a workshop space where makers can come in, get group access to all the equipment and then classes and whatnot to be makers. So now the maker movement is a thing. So when I was at Hack Pittsburgh, I then was like, well, I want access to better equipment. We just had kind of normal shop equipment. And so CloudFab would connect all these different factories together and allow me to like automatically source from them. But the issue is that those factories are still run, like you're saying, like 40 years ago. And so what I looked at is like, if we really want to make fundamental change to the space, we have to fundamentally change how manufacturing and engineering work together. And so, it's funny that in the world today, we think a lot about manufacturing as separate from engineering. But in the software world, we directly connect software and, say, the data center, which is like the factory of software, right? So I think a lot in how we can apply those analogies. So I'll sort of dive in right now. So one reason is like, why should we care about tools? The talk is called The Future of Tools. And I think like as human beings, one of our distinguishing characteristics, the biologists tell us, is tool use, right? And even more so tool making. Not a lot of people get to make tools anymore because they're so complicated. But I'm really interested in how we can make tools for people that are more accessible, that make it so more people can use them. But also I'm interested in tools that make it so existing professionals can go even deeper and have magnified superpowers of creation. So this is sort of what to think about. So I take this back to essentially this graph. So the year 1000 AD, this is life expectancy versus GDP. This is like the material conditions of the world. Our technology directly drives our GDP, which is roughly related to this. And if you want to look even more materially, here's all the inventions and all the people they saved. It's pretty crazy. The physical conditions, this is one reason I'm very inspired by this. Deployment of technology. Look in the room around us, right? Everyone designed, built, manually installed. There are people all over this building, right, that built this building. Hardware is the world. From the cell phone in your pocket to the vaccine in your veins, like we have engineered this world to be better for us. So I'm interested in how we can engineer this world better. And so one thing that's interesting, this is going wild, okay. So one thing that's interesting is this is the rate of adoption of new technology, and you can see these are getting sharper and sharper. And this cuts off in '05. These are like nearly vertical now. And so what's interesting is this is not a hardware story, really. We learned how to make hardware well, but what we needed was shipping and marketing and that entire pipeline to get it to market. So now people figure out cell phones exist, everyone has them, you know? And so that's a marketing thing. So right now, we're getting increased pressure on product developers because now it's so easy to deploy these inventions. Now we need to invent better stuff faster. And so I care about how to make those tools to do that. So how do we get better at solving those problems to make better things faster? So I look at basically different industries by how many iterations they get and how much they cost. So on the software side, every iteration is free and it's instant. It's as fast as you can hit enter, right? That it will evaluate and tell you what the bugs are. In civil, right, if you don't get the bridge right the first time, you're fired. Like, you don't get iterations in civil, right? So it makes them very conservative. And so I look at how software is done and look at these other fields like electrical and mechanical, how many different tries you get, because every try makes the invention better, right? And you can test it with people and iterate. So iteration is a huge factor in how to make better products faster. So how do we improve iteration speed and cost? So here's what software does. You write software and you debug it, meaning you look through the code to see if there's errors in the code. Once that's good, you compile it. You turn a human-readable set of code into binary that a computer can understand. Then you test it, see if it works. If all that passes, you deploy it. Put it on a server, a cell phone, and what have you. That process can happen almost, in a minute, in a lot of these modern build systems. So software gets to work at the speed of your brain. That's why, everyone's heard of Agile and Scrum and all these different team methodologies. That's because your team in software is the limiting factor. It's not the software speed, really. It's your team's ability to understand the problem and create software. So I look at how we can apply these software analogies to hardware to do the same thing. And so the question is, let's step back and say, why is hardware slow? So this is a Corvette engine. I think it's 3,000 components in this engine. Each one is like this, in a CAD software, defined by numbers by hand. So we're saying, make it exactly this length, and there's 3,000 parts, and there's different stages of the part too. So really, there are tens of thousands of unique designs. Each one of these could take from a few hours to a few days, or even weeks or months in some of the very complicated ones to make. How much labor is that? And if you change one little thing, you make the bolt move over, everything that depends on that bolt has to be manually adjusted. So basically, the tools are very low leverage that do mechanical. Unlike software, where if you change a line of code, a lot of times everything just automatically updates and it's fine. That's an instantaneous change. Mechanical doesn't get that. And I'll show you how deep that is. Now, another thing interesting is that we're running 80s code. The software underlying CAD has been written a long time ago, and everything is built on top of this, what they call kernels. And so because of that, it biases how the CAD works. Further, we have big four companies that do CAD. Probably 90% market share of the engineering tools that we use in mechanical come from these companies. So, Boeing is not going to switch the 747 to another CAD, right? They're just never going to do it. And so because of that, they have very high lock-in. So these companies are kind of, we all have our MBAs here, right? Like, we're milking this strategy. And so we're taking profit from this, and really what they do is they grow by acquisition. So they have cool stuff, and they make it another button inside of their interface, but they don't fundamentally change the interfaces. So I'm interested in how we can actually push that. So that's design. Now, this is what factories look like. There's 100 years between these two pictures, and I find that really interesting. Say what? Yeah, 100 years between these two pictures, and they're basically made the same way. Someone is putting the handle on every time, and I've been to the Detroit factory where these are made, and it's still people everywhere. And the issue is the setup cost on this. What's funny is, it takes 3 years for them to get the Model T working. It takes 6 for them to get a new model on the F-150. So we actually regressed in the model year time. It takes 90 minutes of human labor to assemble a Model T. It takes 190 to do the F-150. So we're actually, all the robots, all that stuff, yeah, maybe there's more parts in the F-150. It's a nicer car than the Model T. Sure, but we're not that different. And if you want to change something on here, again, all manual. The entire line is dependent on every little thing, and that's why it's planned for years, because there's such risk. So I want to make different kind of factories, and as Peter said, we're mostly globalizing. We're not changing how factories work that much. Obviously, there's been a lot of advances, but the actual metrics don't tell us those advances actually hit the real consumer. So this is sort of one of the problems. So this is basically a machine that produces metal components. It's a metal lathe. And this screen, which is weirdly blurred, I don't know why, but that screen has code running on it. That code is from the 60s. That code it takes from hours to weeks to make for a single part. Remember the Corvette engine. There are 3,000 parts in that engine. The whole car is like 20,000 parts. So every one of those parts, if it changes, this guy has to do tweaking and tweaking and tweaking. So that's why you can't change anything. So this is all manual. That's the weird thing, is automation, once you get it going, is automated. But getting there can take forever. And so if you remember Tesla, a while back was in like sheet metal hell because they over-automated it. And so what happened was is something failed, and they couldn't trace it down, and they're reprogramming all the robots everywhere to trace this thing down. So they actually went too far in automation because the automation is brittle. It just does a dumb choreography over and over. It can't sense really that much what's going on. And another thing is, man, this is going crazy. Okay, another thing is that manufacturing is very complicated. This is just steel production. So if you think about it, you've got steel, you have every sub-process of manufacturing. There's just so much, and that guy doing it manually back here has to reprogram it every time. So we're just going through all these problems. You don't have to look at this, but this is basically all the different vendors and different types of people involved through the entire process. This is not what an iPhone app looks like, right? Hardware is not an iPhone app. There are people like, WhatsApp had like 20 people and reached 1 billion customers, right, or users. That never happened in hardware ever, right? It's giant teams have to do things like an iPhone or an F-150, and I don't think that is necessarily true. And so, I'm going to show you basically how I see applying those software analogies to the hardware space to actually solve some of these problems. So going back to a sort of modified view of the before, design, debug, compile, run, test. I'm going to show you how Plethora, my company, basically did this. So we have an operating factory in San Francisco, and we built like pretty much the most advanced software to date that does this. So it starts off with basically inside of another vendor's CAD tool. So this 3D tool, SolidWorks, like probably 60% of the market uses this, and we plug into a bunch of them. The red highlights on the part, that's Plethora. So we have a plugin over here, and the plugin essentially lets you debug the part by, it knows every drill bit we have, it knows how big the machines are, all the different constraints. It's built in. Normally, a person on the phone, you like call a guy in a factory and maybe wait a couple days to get this feedback. You do that for each part. Again, 3,000 parts in an engine. It's a lot of time to do this. So this lets you do it in real time, instantly. It'll also give you an instant price. So it'll tell you how to fix it and then let you buy it. After that, it goes into our manufacturing system. So the compile here is you're taking the 3D model that a designer made, and you have to put it into the code that the guy in the machine earlier was running. And so that's called G-code. And so you can see these lines here. That's where the cutting tool in this particular case is moving. That's the compile. This typically takes, again, hours to weeks. We can do it in a few minutes, assuming everything goes right, in automated factories. So what that would let you do is if you do change your design, everything can just automatically reconfigure. That's never been possible before. So this is like the big thing we work on is how a factory can just dynamically do it. Think about cloud computing, right? If you want to run a different website on Amazon, it's very simple to go in the same server to run the same thing, right? You cannot build an F-150 in the Taurus plant. You just can't do it. It's totally different. So this allows you to go more in that direction. And then after we get the code, then we're actually going to produce the part. So here it is at the end of the cycle. It's already been cut in our machine. So we have our own factory in San Francisco. And then after the test, so this is an automated inspection machine. Again, that machine's usually manually programmed, or it's done by a joystick. So in the future, we're basically going to run the same thing, and it's going to automatically inspect the components to make sure we did it right. Because if you're changing things all the time, you have to be very good at knowing if you made the correct thing after you make it. So what's the point? So we talk a lot about iteration, right? So when we go through here, the whole point is that we can get the cost. One, all the people not present in those pictures are not costing us money or taking our time, right? So you can just automatically in a few minutes, probably the fastest we've made a part, I think, is 2 hours from the design coming in to it going out. So it's like really like the machine time and the loading and stuff, it becomes the only thing. And the cost, if you make, like we make prototypes, a part that might cost us $200 is probably a few dollars of metal. So almost all of it we sell it for, our prices are high because we basically are not paying for the human. So we just get to take that as margins, essentially, which is nice. When you go into volume, that changes. But essentially, we want to make things into this, pizza delivery. We think that like the manufacturing model right now is more like building a building. There's all these contractors and all this entire thing. We want it just to be like instantaneous, 30 minutes or it's free, right? So we're like, it's 3 days or it's free for us. But we're getting there. We're getting there. Okay, so that's what Plethora does. That's my current company. So the question now is like, where do we go from here? And who are some of the people, even some of the local people I'll show you who are working on this future. So the first thing is shape creation. What I mean by that is how do you take, we all are familiar with, prototype people sketching, right? There's these cool concept sketches. That's very intuitive. People just start there. But the CAD tools don't work like that. You can spend 5 minutes sketching something that'll take you like 5 days to make in the digital tool set. So I'm interested a lot in how we can make that process faster. So here's a pen-based computing way. So you can actually sketch the CAD inside of, like in this case, a touchscreen tablet. And so that's one way of getting like your intuition more instead of just entering a bunch of numbers. The interface is kind of letting your human intuition go there. Also, this great looking guy on the VR set, that's awesome, is basically looking at the car in progress, right, and able to get a feel for the car, and perhaps even could design it. So, VR is not a panacea. I'm not here to say that VR is going to change CAD. I know that's a very naive thing, but I think there are interesting applications for it that we haven't seen yet. One of them that I really like is this. So Volvo has a virtual experience of the car. So imagine that if you're Volvo, you could actually get some beta testers to take a VR of the thing you haven't made yet. And they can actually tell you what's good. You make a new coffee machine, do the caps actually go in, and does the whole process work? No one does that. We have to build physical things right now. So I'm interested in how we could do VR product testing to really speed the iteration there. In the web world, you can actually, there's websites where I can say, I want 100 people to check the checkout flow of my website, right? And they'll give me notes, and I'll have all the analytics before it ever hits customers. No one ever did that in hardware. We had to build the thing over like 6 months to a year and then get users and then do another 6 months to iterate. So that is crazy amounts of time that web doesn't spend. This may be a way to get beyond it. So the next one. So when we talk about shape creation, that's more about like the thing you're already doing. You're sketching in your brain, right? This is beyond this. This is magnifying human ability. So in this case, so generative design is one of the cool things here. So the generative nature means that in this problem, so on the left, that's like a welded component. So that's made the traditional way. These kind of alien-looking things were generated by computers based on the stress that this part had to undergo. So someone said, I need this part to be lighter. I need it to withstand these forces. Remove as much metal as possible until you get the lightest component that satisfies that. And the computer just adjusts all the parameters until it figures it out. They're using this a lot in aerospace now, not just for what's called lightweighting, but for thermal and vibration and all these things. Whatever you want the computer to do, it'll just do it. Humans couldn't make this. It's beyond human comprehension to do things like that, but it is possible. Right here, local favorite, Topology from New York. They are basically making a specific kind of CAD software that allows you to do these problems. So if you look, it's like a lattice set of elements. So those elements, you could never by hand sketch them. And even if you could, you don't know the mathematics of physics to actually do that, right? And it would crash the current CAD systems because, again, the kernels were made in the 80s. So they've made an entirely different kernel based on new mathematics to be able to represent this. So this is a huge step forward, and they're doing really well, actually. So props to Topology. I'm sure they're hiring. Yes, love those guys. And so this is another thing. So going back to software, so this is the idea that this is actually a machine learning, sort of deep learning algorithm that is taking someone's sketch and making the full code for a web page out of it. So this is like kind of replacing front-end developers, obviously just one piece of their work, but this kind of automation allows us, just in that sketch with a CAD thing, what if the CAD was like, oh, that's a circle, that's a bolt, that's, it would just figure it out from your basic sketching. We're obviously nowhere near there, but this sort of points the way, even without sketching. So this woman never existed. She's a computer simulation. This is basically, you can see big nose, pointy nose, makeup. You can like adjust all these parameters, and the machine learning algorithm knows how to make it look like that. So, what I want is like jet engine, thrust, everything else. So you could actually adjust it, and maybe we would have models that would be able to do that. So very basic thing with a picture. Obviously, this is in the future, but again, we're talking future. So this is just some ideas of what's already possible right now in papers. So that's magnifying human stuff. What if you wanted to see what people already did? So if anyone used McMaster, if anyone's a mechanical engineer, you've used McMaster. And so they build, they have all these components, bolts, motors, and whatnot. And you can get the 3D CAD, you can get the spec sheets, highly manual, but it's still more information than most vendors have, where you have to call someone in like Akron, Ohio to get the specs on the pump. That's like mostly what happens. So this allows you to do this in one place. Actually, where's Sam? Sam, local hero, right here, Octopart founder, built this company essentially, as he has just described, as the kayak.com of electrical components. So basically indexing all the different vendors and then letting you see everything, which this just took so much time before. So yeah, that's awesome that it exists. I think more things will exist like this as well, as we just start to understand the like hundreds of millions of SKUs that exist in all these components, which are locked up in like PDFs, and like some guy named Ed in Akron knows everything. Why isn't that on the internet? That is what we need to get through. And then there's also, anyone use GitHub in here? Any developers in here at GitHub? So a lot of people. So there is one of those for CAD. And it's called GrabCAD, and you basically can download other people's CAD files. So instead of saying, oh, I want to auto-generate my own stuff, you could say, well, someone already built this. I'm just going to take that for free. And then people also collaborate with their teams on here. So that's another thing to make iterations faster. If your team effectiveness is better if you can collaborate somewhere. This is kind of cool, too. So this company was acquired by Amazon, but PartPick scanned a lot of parts. And if you have a bolt you don't know what it is, it'll actually use another sort of computer vision machine learning thing to figure out what it is. And then you can order the part from Amazon as they like. This is the ultimate. So this is actually a CAT scan, an industrial CAT scan of a remote control. And it is fully 3D, and it goes all the way in. So you can see like screws and the vibration system and the board. This actually, Fraunhofer Institute in Germany is getting this down to the micron level. So to the point where you could fully capture the device. Now imagine if you use machine learning, you could actually, one, you might be able to read the chips and understand which one it is, but you could at least tell the pins and everything maybe, and eventually we could fully reverse engineer this thing automatically. That's like super deep future, doesn't exist, but the data is there. Hardware is all open source, so to speak, because it's just all scannable and out there. So that's reality. So this is kind of the craziest one. This is systems engineering. So one of the huge problems in humans is just grokking the complexity. So this is like a fighter jet or something. All the subunits are over here. These are all systems of equations. So maybe Lockheed can do this. But there's a lot of problems in the world. Actually, the recent 737 MAX incident, notwithstanding, like having good models can prevent this. And these are so complicated and slow right now that those kind of incidents happen. Although maybe that was also a corporate governance problem, who knows? But the engineering thing that was going on was very complicated, and so we can understand how mistakes are made. We don't have good simulators of this stuff. So let's talk about that. This is currently how we simulate in CAD. This is what's called a finite element model. And essentially, it's pushing these arrows down. That's like the stress, and then the colors are the stress, kind of hot spots, so to speak. And so right now, this does not run in real time. A person has to set this up. It takes many hours, even days, to get a simulation of one component. You can see there's like a theme here, right? It's like really manual to do everything. And so really what we want is, I want this. I want like the Matrix loading program, right? Like, why can't we just like drop a glass in software and it shatters on the floor? Like that actually would take forever to do right now. And imagine you have a whole jet you want to simulate. It just won't be possible. There's a lot of interesting things coming in this. I mean, all the way from AI being able to make the problems easier to compute, even to like wild pipe dream things about in the chemical world, for instance, quantum computing can actually simulate chemical processes down to a very low level. We're not close there yet, but this is part of the tools that are coming is, quantum allows you to explore a huge multitude of combinatoric explosions that classical methods wouldn't be possible. Simulations suffer from this huge problem of so many things interacting with so many things, and quantum can help you collapse that space, basically down to a different kind of problem. I'm not going to go into quantum because I don't understand it. But basically, I think simulators will get better over the next few decades as well, which will really aid in our iteration time. So my world, manufacturing. So I think that the machine tool on the left should look like the one on the right, the server. And so a lot of our company, was actually figuring out how to make the machine tools not require humans to program, use, or anything else. And so, a few people are doing that. So there's Plethora, there's my friend's company, Tempo, that does it for electronics. This is a full stack approach. We have our own factories, we have our own software, and we deeply solve the problem in one domain. But when you go deep, you're also narrow, right? You got resources. So we're going to slowly do each process over time by making them more and more automated. But then other people, so Xometry and Fictive and my past company, CloudFab, we're marketplaces. So we get all the people that exist and just make it easy to interact with them, and they go broad very quickly. You can make anything. But it's as slow as normal processes, but it's more convenient because you don't have to make a bunch of phone calls. And I think both of these will exist in the future, and I think the full stack will just slowly eat a lot of these until we get into the specialized stuff that you really should talk to the people because you're co-designing it with people that are doing very complicated processes. So that's kind of the future. I don't think we're going to get away from phone calls fully, but I do think we're going to slowly consume a lot of the bad ones. And so another neat thing, if you're having a factory and you have to build it, they're also using VR for this now too. So they're building the entire factory digitally, and people are walking through and even placing components to see if you can ergonomically move them or if it's safe. You can do these studies before building the factory, which is nice. They also do the same thing with the assembly. So this is, weirdly, there's a video game now called Wrench, and people just have fun fixing engines digitally, which I just find fascinating, but that's a thing. And it's like, learn how to overhaul the engine. It's like you could go to a garage, but I guess it's cleaner at home. But they actually have the entire engine model, and you are putting in the pistons and I guess torquing down the heads at this point. So yeah, this could also do it if you're Ford and you want to model the engine. You can do the same thing in VR, which is pretty fun. And so as we talked about before, this was imagine the Tesla welding line. This is basically what they would have had the hell dealing with. And so these robots right now are completely dumb. There's not a lot of cameras anywhere, right? They're just doing that thing over and over. But in the future, these actually will. And we're getting there where we can sense differences in the metal. We can sense We can load in the program and it will just automatically program itself, unlike what today is someone with a joystick basically moving the robots around very slowly and hoping that it works, is the state of the art pretty much. So we will get these auto factories, but it's deep future right now. It's not, like Plethora can do little bits of it, but we can't do the whole car yet. So just to recap, I think that this is sort of overall a future of tools. You've got your intuitive shape input, you've got your augmented design that allows you to generate designs directly from sort of basic inputs. The computer designs it. You've got ways of actually figuring out what exists and how to get that into your, into your design quickly. And then you have how do you debug and simulate the parts so you don't make mistakes before it hits production. And then how do you make production, way more effective and faster and more agile so you can do your prototyping better and so you can move your production as you need. And so that, to me, is how we build engineering superpowers, which is what this is all about, is superpowers of creation. And that is sort of my goal I've been at for 12 years. So thank you. Nice. Cool. Wow.
That was awesome. That was awesome. Superpowers. Okay, so let's bring up the chairs. Can we bring up the chairs here? And we've got that was a speed talk. That was so fast. So I'm gonna
I get
actually
excited. I get excited.
That's awesome.
It's hard to talk slow.
It's totally the way to go. And I was taking notes furiously, and we're gonna walk through a little bit about this.
Okay.
Thanks.
Indeed.
For that. So let me just review a little bit about what you're doing here.
Yeah, sure.
So you're talking future. So give us, just like I was kind of saying, okay, there's this digital story that started in the 80s, and here we are. It took 40 years of this kind of thing, right? And we're kind of, even at this space, we still got ways to go, AI and others that will come out of this stuff. Same thing with globalization. It took a 40-year thing to kind of really work itself out to where we're now, whatever, in the trade war with China and all that, right? But when you look at this kind of thing, just give us a little sense of the scope, like the timeline, because you kept saying future, deep future.
Yeah. It's hard to say in many ways, right? I mean, some of this stuff like Plethora already exists, I would say that it's interesting, they say that the knee of the curve, or the exponential function, right? These technologies get better exponentially, so it's hard to see when the knee actually happens. AI is sort of like that. 10 years ago, neural nets were like, oh man, that'll never work, and now everyone wants to, and maybe we'll become disillusioned. But some of the things in there, I would say, are like a decade away in the future category. Like the generative stuff works now, but it's not like every car is built with generative stuff, right? And the 3D printing technologies needed to make it are still very much in their infancy as well. But what's interesting is you're seeing kind of Gartner hype cycle, sort of S-curves happening where 3D printing, when MakerBot came out, that was like the 2.0 version. It was like, well, first 3D printers were very expensive and slow and the materials sucked. Then MakerBot, the quality is still bad, but it's fast and 10 times cheaper, 100 times cheaper, so that was good. And now we're actually getting better quality, and we're getting metals and ceramics and sort of exotic things that let us have higher performance. So we're seeing it in the performance market, like the GE LEAP engines, for instance. The blades inside the engines are printed out of a single crystal of what is called a rhenium nickel superalloy. So this crazy exotic material, which is made in another crazy way, grown as a crystal, then machined, and it's actually, I believe the crystal is made in a 3D printer, weirdly. It's crazy. Don't ask me how they do this. And then it's printed hollow, so they can blow air to cool it, and then they coat it. So what happens is the heat from the engine, you want the engine to be as hot as possible because the difference between the hot and cold side is how efficient it is. So the hot is actually hotter than the metal can take. And the coating, if it just flakes a little bit, the engine blows up. But it's 30% more efficient with fuel, so that's going to be good, right? So they made this engine and pushing the edges of what's happening. Right?
So this is in the Nissan Leaf. It actually is how they do
it.
No,
the Leaf engine is
Leaf,
it's in the 787 Dreamliner, I think, right now.
I see. Okay.
Yeah, and it saves a ton of fuel. Yeah. So this is where it actually comes out to, is it's saving the environment because we have 3D printers making single crystal turbine blades. It's crazy. That's where it leaks into reality.
Well, so I'm hearing what you're saying, but I'll push you one more notch on that. So
keep going.
So if you were young person,
I'm not.
No, but I'm saying, I was going to make the analogy to the 80s or something.
Yeah,
you say, oh my God, these computers are going to be the thing, and someday we'll even connect them up, and oh wow,
it'll make democracy way better.
Yeah, exactly. It'll be that kind of thing. I mean, is there a kind of way to think of this hardware revolution? I mean, for example, everyone's flocking still to the digital thing and, whatever. On the other hand, why, if you had to tell the story, would you say, hey, we're kind of in where we were in the 80s or the 90s? Or, I mean, where are we in this journey of kind of this transformation of hardware?
I think it's super early. I mean,
70s,
if you...
Or,
well, no, I mean, it's hard for me because I wasn't from then, so I can't
Yeah,
I can't say what it
that's
felt
true.
like. But yeah, let's go with like 80s earlier. I mean, if we're thinking about like the computer I used in the 80s, like in the early 90s, I guess, like the DOS machine that only like relatively skilled people could understand how to do that, not as frequent as today. I think we're not even there yet. Like hardware it's still highly manual. Like we don't even have this inflection point at that point. It's almost like the Altair. We're like a little bit after the Altair from like the 70s maybe in hardware. I think we have much to go.
But if you were advising someone in a career, I mean, this seems to be a lot of open space, a lot of opportunity.
Huge
I mean,
open
it's a
space.
huge kind of, as opposed to the kind of crowded digital space we're in right now, right?
I think that's right. I mean, what we found is it's like, I did one manufacturing process. I did CNC machining, and only partially for some things.
What is CNC machining?
So CNC machining is when you take a block of metal, plastic, wood, and you carve away what you don't want, so the part remains. And the CNC means computer numerical control. So it's a robotic cutting machine, basically. So they took what my grandfather was a machinist, a non-automated one, and what he did with his hands, we do with computers and motors today, and that's CNC. That's one process. There are hundreds of manufacturing processes. You can make billions of dollars automating any one of them, and that's the opportunity just in one little space. Then there's all these sub-units in the entire problem. So it's really huge. I would say right now there are just no founders who know about the problem. Because it's like, I was lucky because I grew up around machinists. My dad was a production manager in a machine shop, and my uncle had a machine shop, and my grandfather was a machinist, so I was around it, but I also liked computers, and so I was like, oh, this process sucks, and then I know computing, so, then you learn the math, and then you can do it, but people don't do that. Like you go to Stanford, no one's like, oh yeah, I love getting my hands greasy. Not that many people, everyone's like, fit for dogs or whatever. It's like it's just, it's like a different thing. That's how hardware looks. And I think that like people just don't think about it. And even the people, say who work at IDEO, or a consultancy or something like this, that are like making consumer products, and that's really cool. And people don't come back and say, well, hardware is one thing. We just had like a big uptick in hardware over the past 5 to 10 years from just, I think, the investors and that kind of whole pipeline got built out more. But in the industrial world, it's still very much in its infancy. And I think that the MakerBot thing was the first blip. Then there was like kind of the winter of 3D printing. And now we're actually seeing a lot better companies coming out. And not just 3D printing, we're seeing things like Plethora and Tempo and Xometry and all these guys coming out that are doing good work in the space. So there's actually just not enough founders, I think. There's enough money now. It used to be that the investors wouldn't give you any money. And it took me forever to raise the first like $1.5 million, and I failed the first time and this whole thing, but eventually did it. But now it's like there's a couple cases that were proven that like, okay, there are real billion-dollar companies in this space, and so now you can invest. And I think now it's like, but who can you actually put money in? Who knows anything? Because they're very hard problems. So I think that's actually the main thing. If you're a founder and you actually want to solve these problems, you know about them, it's a really good time to be alive. Like that's for sure. For sure.
Well, that's really fascinating, though. I mean, do you? I mean, one of the reasons when I'm hearing you say that, I'm also kind of thinking of the bigger picture. Is part of it because the high-end design and kind of engineering was kind of stayed in the United States and in Europe, and all the kind of get your hands dirty manufacturing was often happening in China and other places now, and it's just that we weren't really putting our heads. The young people weren't putting their heads into those problems since they were just getting solved by somebody over in China, right? Is that maybe part of the problem here? It's just we haven't really wrapped our heads around this.
This is really interesting, right? So actually, I had this whole thing that came out recently that was like the sort of the tweet storm in industrial policy that became a podcast, actually. So if you want to listen to an hour and a half of industrial policy, it's out there. It's on Palladium. But regardless,
that you literally
yeah, it's
did.
me. They interviewed me about the industrial policy of this stuff because basically the history of machine tools in America. So the CNC machines that we work on were invented basically by the Air Force in the 50s at MIT. And so that happened all until the late 70s. America had the top 10 companies that produced those machine tools. And what's interesting is you can see there's different milestones where basically like the US government via the military put a bunch of money to develop this technology to make better jets. That was essentially what happened. And then I think what's interesting is the coast theory of the firm, right? The whole idea of like, should things be done in or outside of the firm? Everyone's like, let's outsource everything. Why do we need, like manufacturing is a commodity, outsource everything. And so that went to China. And so then that was one thing where we started outsourcing stuff, but also those machine tool guys, like they essentially they were not profitable. We're a capitalist society. So those companies made no money. And those companies still make no money. So, the Germans and Japanese tend to do that, but those companies make like 2% net income. So no one wants to be in that business. But those countries actually give them very cheap loans because they actually maintain a broader system.
Germany and Japan.
Yeah. So I mean, if you want machine tools or robots, you go to Germany or Japan, maybe Korea. It's like people who have deep industrial policies made those big investments. And so America was like, what do you mean? Like, our private equity guys can't flip this? Or, no. Well, it doesn't work in our system, And so it didn't exist, and then they all died. So all those companies are dead now. There's one American manufacturing company that makes any profit. It's Haas Automation. I think they make like 25%. That's as good as a manufacturing company can get because they're really aggressive and they're cost cutting, very highly modular in the machines, a bunch of stuff. But if you want to talk about like Fanuc, the giant Japanese company, has 70% market share of machine tool controllers, like the brain of these machines. They started in the 80s. They were spun out of Fujitsu, out of there. Anyway, I could go on forever, but basically, like America stopped investing in that as a policy from the military, and also other countries wanted to do it. So obviously, those countries did, and of course, China did. And then they were able to reap a bunch of benefits because if you go to Shenzhen today and you go to the Huaqiangbei district, and Huaqiangbei is this amazing like Blade Runner place, you can just get anything done, and everyone knows all the very specific skills to do that. It's amazing. So like, there's probably more retail like manufacturing in Huaqiangbei, China, than like all of America. Like, I think that might be a true statement. Yeah, all of our Radio Shacks are gone. I'm not even sure where you go anymore. Yeah, it's kind of crazy.
When you say Blade Runner, what do you mean by that, Blade Runner?
It's just like the future. Yeah. I'm like, when I'm in Huaqiangbei, I'm like, whoa, there's like, one, it's like signs advertising chips, It's like really funny. I just think it's really weird to have that. Then you walk around a mall full of like reels of components, that you can just go everywhere. Actually, I've been Sam has been there a million times, I'm sure.
I was there in November, and actually it's starting to change.
Oh, really?
Can we just get you, as long as because we are in the...
yeah, good idea.
Could you just stand up and introduce yourself and say that right there?
Yeah, my name's Sam Wurzel, and
you run that company? Which
Octopar, I used to. It's a search engine for electronic components, and even the electronic component industry in Shenzhen is changing now, and a lot of it's going to the web, and a lot of the open-air markets are starting to shut down and to be a little bit more focused on web-based e-commerce.
Interesting.
So even that is starting to go the same way. Interestingly, the whole electronics industry started in Manhattan, where the World Trade Center site is, which was called Radio Row. After World War II, all the surplus radar gear was down there, and that was all cleared in the 60s and 70s when the World Trade Center was developed. Anyway, I'll stop, otherwise I'll get out of control.
No, we'd love to hear you more. But
That's awesome.
We'll come back to you in a minute. So this is, again, we're weaving together a tapestry of a world that, like, who knew, What's that? It's so interesting. Yeah. Well, so what's interesting, though, is how this might be shifting. Like, honestly, it's like if you're talking to Dustin Hoffman or whatever in The Graduate, you say, what do you do? Plastics or whatever. Every kind of moment has, what are you doing? Would hardware or what would be the kind of Dustin Hoffman quote or something you'd say right now? Wouldn't this be one of them? Why crowd into, hey, you're another kind of digital coder dude? Why wouldn't you want to do hardware for the next 40 years?
I'm fully with you. When everyone else thinks it's a good idea, then it's a bad idea, right? So you want to be earlier than the entire consensus. What's interesting is it was really hard. Like actually, Union Square Ventures, very close to here, funded a bunch of companies in like 2003 to 6 maybe that all didn't work because it was way too early for hardware and the market and everything else wasn't there yet. Then we had a little bit of a resurgence with MakerBot of like 2009 or 10 or something like that, and then this whole thing happened, but there was like a couple different bumps to get it over the peaks.
Could you explain the MakerBot thing just so people get a little bit of handle? Because again, people are, you know so much, we just translate a little bit.
No, I appreciate that. Put on the brakes, Peter. Okay, so MakerBot, local company started here. They made 3D printers that were affordable. So they took something that was normally $30,000 in a lab, and they made it for at least originally about $1,000. And so this was it was open source, so the plans were on the internet too. So hobbyists went nuts, people just buying components and making them, and then later they built kind of full machines. And so that company was then acquired by one of the biggest companies in the 3D printing space, Stratasys, for like, $700 million or something, and then kind of existed. But it really was the catalyst for early manufacturing startups could be a thing. And I knew them because of the hackerspace movement, and that's just what was happening at the time. And a lot of people probably don't know that New York was like the center. So OSHWA, the Open Source Hardware Association, was started here. We were going to the conference in Queens. So it's interesting. A lot of those people are still here. I have a Deer of Little Bits. was there. Bree Pettis, he's at Bantam. There's a bunch of locals who are there, interestingly. But yeah, so once people said like, oh wow, a big acquisition happened in 3D printing, then there was more and more stuff that happened. But it took a few years because MakerBot, like, there was no other MakerBots in production, you know.
Okay, and then, but again, there's a San Francisco version of this and that, you know, you've got venture money, I mean, a lot of it, from what I understand,
Sure.
for plethora. So why, or
Why
maybe
now?
this is happening, why aren't young, you know, digital entrepreneurs starting
Yeah.
to shift? Why isn't that filling out quicker than you, or maybe it is filling out?
So
Just tell us
I
what's going
don't-
on there.
It's way more than it was 3 years ago. Now there are companies that I see that are actually like, you know, some people that are copying stuff Plethora is doing, and I was like, okay, interesting, like, and they're getting money. So I do think that, you know, some of us were successful and raised money or exited already, and those were good wins for the financial people to do that, right? But what's interesting, I think that in the world right now, we were, like, if you ever read the history of like JP Morgan and Edison, for instance, like, I got a better venture deal than Edison did. The terms were horrible for Edison. And so it's kind of funny, like when JP was doing it, capital was scarce. And so he took European capital, deployed it here, and, you know, built out everything. Capital's not scarce anymore. Money is like pretty easy if you're like reasonable and good. So I think now founder scarcity is actually the major thing. So I would say like, I would love to see people doing way earlier stage incubators that are almost like taking academic kids out who are like, you can read papers. One, the NSF doesn't spend on manufacturing research at all. I'm sure like Germany, Fraunhofer or something is, but like spinning that stuff out into companies and getting a whole pipeline, I would love to see that before they're even seed fundable. Because, you know, I advise a lot of these companies actually. So there's founders who are like 2 PhDs who know a lot of stuff except any business. And so then you have to like coach them on, you know, raising money and all the different, you know, finance and hiring and stuff. And so that's what I find. It's actually a people problem. At least that's my read. It used to be a capital problem where investors didn't believe it. Now I don't think that's true. There's enough success where they believe it.
Well, so, I don't know, it's always like the next generation, let's say the Gen Z, who's, you know, these 14-year-olds like doing Minecraft, you know, over and over, and they've watching YouTube videos of how to build shit in, you know, but in, you know, this virtual world. I mean, will that be the crew that'll just look, oh, if I can do it in Minecraft, why don't I just do it here, you know? I mean, maybe there's any sense of that going on?
They do that. I mean, I am now an old man compared to those people. So I've never used Snapchat before or whatever the kids are doing these days. So I don't know. But I do think that like the revolution in the, like you're saying, like people learn Minecraft. And what's interesting is you're seeing a lot more games include building elements, I think, than they did. There was almost like, there was a period where the games were just like shooting everything, you know? And obviously that still happens. But you know, now things, I'm trying to even think of modern games, and now I'm like also feeling old. I can't think of any modern games, but you know, a lot more simulation and building based, like Minecraft is like the prototypical one. And so I do think they are, but I haven't seen it directly yet. I see a lot of young people who are that age who email me, actually, wanting advice on stuff. So if that's anything, I do see that a lot. And we're just seeing the accessibility. Now that it used to be we're making, you know, boards was something that would be really hard to do. You go to Radio Shack and all this whole thing, and now you can just buy it off the internet for $20. That is definitely changing stuff. And you see it, actually, I went back to my high school, middle of nowhere, Rust Belt, Pennsylvania, and they have a makerspace, which I think is pretty cool. And they've got like a 3D printer and a laser cutter and a little electronics lab. And, you know, we had nothing. Like I didn't have metal shop when I was in high school. So it's kind of crazy.
I've also been picking that up. It's very interesting. All the different universities I go to, or even high schools
Yeah.
and stuff. It's interesting how that's becoming baked in to the next thing.
Totally.
I mean, you know, honestly, when I was in school a long time ago, high school, we got exposed early to computers, like in the 70s. This is dating me a little bit, but advanced computers just happened at Minneapolis was a big hub on the computer industry in those days. And the same thing is when you're exposed early to something cool, particularly that's more future oriented, it's like you get into it, and then you want to roll. Anyhow, I'm going to shift to a couple things and then just be thinking, folks, about questions you might want to ask Nick. But the thing about building things differently, and this is now I'm going to stretch you into your kind of big picture thinking guy. To what extent do you think, I talked about how the last 40 years of globalization, supply chains, global, all that, but it's also, you know, the same time we've essentially, you know, spewed carbon into the atmosphere, climate change, and this global supply chain might not look like such a great idea anymore. We're flying all over the place and we're, you know, moving stuff around. Do you think the kind of local manufacturing in a kind of a way that you're talking here is essentially a meta pressure that might actually force more interest in this space, or kind of, instead of having it, figured out in China or whatever, it's got to be local and,
I
for
don't see it
transportation
as
reasons,
much.
anything like that? Okay, that's too much.
What's interesting is like it costs like $3,000 to send a container from Shenzhen to Long Beach, and like imagine how many cell phones you can fit in a container, right? It's like pennies or tens of pennies, to do that. And imagine the carbon from that. I mean, okay, let's get bunker fuel out of them and let them burn like actual diesel so they're not putting sulfur in the environment. But other than that, I love ships because it's the most effective way of moving things cheaply and with less carbon. So I actually think ships are fine. And I think that like building a bunch of factories is not good for carbon either. So I think that when you look at it, it's like, they're building cars on the continents they are, maybe for tariff reasons, maybe for, other like shipping reasons. The shipping is expensive for big things. So I can see that, but I don't actually see us deglobalizing that much. I actually think economies of scale and scope actually still are dominant in the industry for a long time. Like even Plether, right? We're building a big factory now, like another factory, and it's a central hub factory. And we are going to do more local things, and I think for prototyping that makes sense. Maybe we'll do more custom stuff, but that will actually be less carbon efficient, I would bet. But it'll be in net better for the end user, and hopefully we'll actually learn as a society to do carbon taxes or something to like offset this stuff. But I don't see it actually providing that meta pressure in some ways.
Okay. I'm going to open a couple questions to you that's going to go beyond your industry-specific thing, because you're wrestling with, like you mentioned industrial policy, and you've been thinking about economics and various things, economic policy, I know from other spaces I know him have been. What I'm interested in is you are part of, even though you're in hardware, you are part of the young millennial generation of kind of tech-savvy folks. But there's been this tech backlash.
Yeah.
In San Francisco, New York, all over the place. I mean, do you see that cohort in general starting to take more responsibility for outside the industry, outside their business, outside the field, and start to actually apply more innovation and more money and all kinds of different things in a more broader-based retooling of the economics or the society that we're kind of living in? Any thoughts on that, kind of how you think about this?
And if I had one quote for it, I think that the tech community needs a little less talk and a lot more action.
Yeah.
In that world. I think, in San Francisco, people like to talk, people like philosophy, and political philosophy, and everything else. I am guilty. What I've been doing, though, is that actually just being like, maybe, I'm running these fundraisers for different people to swing the House last time. And, it's like, let's actually do real politics now. And so I've actually been trying to organize the tech community for, like, traditional politics. I do think that the tech community really wants to do this stuff. The structures, the superstructure, as the Marxists would say, doesn't actually cooperate that much. So it's like you can't get a lot of money for companies that don't make money, right? And so we have to figure out how we're doing that. But the impact scene, I would say, has had much mixed results. And I think it's quite early in there.
Say more about that. The impact, meaning impact investors.
So there's impact investing, right? And that's a whole. And there's all these different sort of tranches of it. But at least what I've seen, there's not been a ton of like super scalable things in that I've seen that make economic sense. So it's always subsidized, and so it's very hard to grow when it's subsidized in a capitalist economy, right? So that's difficult. Now, there's a lot of companies. I would say that, as I said in the beginning, I think technology, just without any of the CSR stuff, actually is a great thing for humanity in general. I think technology is great. I think that its externalities, like what Facebook is generating, right, as far as like all these issues with it, I think the big tech companies are guilty of some of that stuff, and I don't think we're adequately putting pressure on them. There's an interesting divide between the big public company and sort of VC class that must sell their startups to the public companies, that interest group, versus the startup people and everyone down to like a Uber driver or something who want actually a fair system, I definitely have friends who have things that would otherwise be competed by Facebook, if they weren't acquired by Facebook. And so I think that is a bad dynamic, that there's actually a division in Silicon Valley between capital and labor, counting myself labor in that.
Labor as founders as labor too.
Founders and everyone below us, yeah, for sure.
Do you envision, because I know you've been thinking about this, do you see some in the next near term, 10 years, kind of 20, 30-ish, your generation takes more
it's, right now.
Impact, do you feel that the inequality issue and the economics around that might get worked out in new ways?
God, I hope so, right? I think that people recognize it as a problem. I'm glad that Occupy and everything actually had a little bit more of that stuff go out there, but it's still very early. I think people are very complacent. It's easy when you're in tech to just Instacart everything, Uber everywhere, you're completely sealed off from the inequality. New York is a way better run city than San Francisco. I'll just say that. I think that is totally true from just what's going on and how we treat everyone.
In
a like,
terms of
government sense.
through
Yeah,
classes.
I think that people feel the experience of inequality way worse in San Francisco. Like the percent of homeless population that's unhoused is very high. And a lot of things are bad, and people are very complacent, I think. For whatever reason, the government's ineffective. People want to change it, no one's doing it. Anyway, but I think that people are just kind of waking up to doing things because I think everyone's just pissed at this point, frankly. My friends are. There's probably a few thousand people in my friend group that are sort of like this, and we're more politically active, and I think it's still nascent. I would say overall, I've not liked the lack of leadership in the tech community. There's been a lot of failed attempts of sort of the billionaire tech people trying to do these political initiatives that they never actually talk to people who do the work already, and so they do these kind of naive things that don't work. So in that way, I would criticize the tech community for not actually talking to the practitioners enough or dismissing them too early. I've been trying to actually talk to those practitioners to be like, okay, let me learn from you and just, if we were going to make a company, we'd talk to our customers and ask what was wrong, right? And we would say, how do I build a service or product to help you? The tech community is not doing that approach with politics. They're like, no, we know better, we're smart. And that's not true, right? We should talk to the customers who are in the nonprofits and the political campaigns and so on. And so I'm sure people are doing that. I'm trying to do that. And so that's at least my approach in doing so is listen to the customer, And so far it's proven way easier to get into politics than I thought it would be. And I was like, wow, this is encouraging. No one knows this. Everyone's apathetic as hell. If we showed the progress, because ever since I did these fundraisers, now everyone's coming to me asking about political stuff. So it's been interesting, but it's very early that I find it for my personal experience. Interesting.
All right, hey, I'm going to open it up here, whether you want to talk business, tech, politics, whatever it is. There's all kinds of stuff here, and I will lob in an occasional question as well. But to do that, we need folks to, here's a question here, but wait for the mic, and we'll do that, and stand up and just introduce yourself. It's partly for the video. Could you stand up at least, so it's easier to...
On?
Was it not working?
No, it's working. It just, there you go. On? Hi, thanks. Very, very interesting. I think your basics, the sort of work you're doing, obviously to automate and make sure that sort of one change can sort of speed through a process rather than perfect makes lots of sense.
It's my shtick, yeah.
Yeah, your shtick, super great. And I then, very interesting sort of talk about sort of where you stand politically about, you considering yourself part of the sort of bottom of this kind of working class divide.
In that one issue, maybe.
Okay, yeah, exactly. Yeah. What I noted in your, that you still are, it seemed, and maybe I'm confused, that your mechanical change, that sort of, the awesome iterations still seems to involve taking these things through factories where nobody's working, and this stuff is all automated, and actually eliminating all the people like your father, your grandfather,
That's right,
all those people.
For sure.
Is there any,
So yeah,
so
I can
is there
talk to
actually
this,
any opportunity for there to be kind of a combination of those sort of, you like workers, and at the same time there clearly seem to be problems about the sort of timing and changing.
Fully.
Is there a way of actually finding some middle ground which involves both automating what needs to be automated, but still actually letting some people work?
So it's interesting. So we are in luck. There are a few things that are lucky changes, I think, for the 21st century of labor. One is that it's actually better and more productive to treat your employees well. We're really lucky. I think 200 years ago, that wasn't true. So actually, people like Google who treat their people really well actually get more productivity. That's a really happy, lucky circumstance. In this case, what's interesting is automation, and I have lived this the past 6 years, never goes from fully manual to fully automatic, And what happens is all the people my grandfather and my uncle, their brains know everything. And so, and a lot of subtle things. And so you have to have them for a decade as you're doing this. Plethora was 6 years. And a big part of our thing was actually culturally how we could get the machinists to talk to our mathematicians, who obviously speak a little bit different language. And there were weird problems, right? Even class problems where a lot of the blue collar guys never used email at work. And we had to train people on how to do that, and just interesting stuff like that. So what Plethora does is it's not full auto all the time. It's manual on almost everything somewhat. And so what happens is it's more gradual. So what's interesting to see is, of course, Plethora is not at a scale that you would see this in the economic numbers, but if you look at the Bureau of Labor Statistics in machinist, the category that we replace, you'll see that there's two things. One, the amount of people working in machining is going down, which you would expect from automation, and productivity is going up. But the reason is actually because of aging out. So what's interesting is like they're aging out, but people aren't going to trade school enough. So now they're building all these trade schools. Like the company that I mentioned that was very successful, Haas Automation, is now building their own trade schools to get machinists who are qualified to run their machines in the factory, because the people who own these factories say we can't hire anyone, or it's people in our shop can get paid $100,000 to run a machine. It's San Francisco, but still, it's a very lucrative job. And so that's actually more about young people not going into it and there not being maybe enough workforce money in the budgets to do this. But I think actually it's a more gradual process a lot of the time. You see sometimes some plants will just go, in a year for certain things. That sometimes can happen. But I think that a lot of the times it's a lot more gradual than that with significant automation.
You also described Germany and Japan as having embraced this kind of alternative model about what's profitable and that there being public value in there doing something.
Could you grab that while you're saying that? Yeah.
Sorry. So you also described, though, Germany
Yes.
and Japan embracing alternative model that we decided we were not going to support.
Yes.
But, X amount of profit. It was too marginal to actually be worth investing in.
Yep.
Is there not room for your model, for your system to, given the value you've seen great public benefit to the Germany and Japan embracing the alternative, is there no way of actually integrating that so that it's not simply an issue of aging out, but rather you actually see that there's public value?
It's a great question. I think there's two parts of this question. One is, was America wrong to lose that stuff? Yes or no? I think it is not a clear yes or no. I would say that, what was the machine tool companies that we actually kept? They're the semiconductor companies, right? So like the people who make semiconductor stuff, we talk about let me think, Lam Research, Applied Materials, those things are actually the top 3 of them by market share, all in the United States. Those machine tools are still here. And the military also supported them, right, the chips industry. So that industrial policy lives on. I'm sure they'll eventually move to Taiwan as Taiwan Semi and everyone consumes that industry, but it'll take a while. So it might have been the correct move to say, wait, we can get commodity machines from Germany and Japan and not pay anything for it? Why would we want that? Now, maybe the innovations in that space we lost, but what's interesting to look at is it's not like Germany and Japan built plethora. Actually, one of my investors when we first did this was I'll admit this, it was Peter Thiel, which is not the best name for me right now, being on the other side of that spectrum. But this was 5 years ago, guys. Anyway, I actually really like Peter, but anyway. So he asked me a question, which was, why didn't Japan or Germany do this, right? Because they have all the people, right? And I agree, but I think they don't have the entrepreneurial ecosystem to actually do it. So maybe they do have that, but weirdly we did it. So that's a different question on industrial policy. Were they right to invest probably tens or even hundreds of billions in maintaining factories that have very little profit and maybe are a deadweight loss in a sense to those economies? And was it better for us to do machine tools for semiconductors? Maybe that was true. So I don't think it's a clear case. That's one question. Your second question is sort of could we subsidize these jobs, to do this, is what it sounds like. Could we give cheap loans like Germany or Japan does as an industrial policy to these companies? And I would say that as just a very basic kind of capitalist measure, I always look at the IRR on investments, right? And so I look at that and I'm like, well, there's a certain return that would have, and then there's retraining people for new jobs. And so I actually think that my intuition, I haven't done the math, my intuition is we should train people for new jobs and let the things slowly go away, and that's just progress. I think if we look at labor mobility in other countries who do a lot of that stuff, you see crystallized things and low growth. And I actually, I put the GDP chart up there. I'm very much a fan of GDP growth. I just want inequality to go away. So I want higher taxes and redistribution and good public services, and you need to have more and more growth to do that, to fund that stuff. We want to make more GDP. We just want to adjust for carbon and adjust for inequality. And Europe did that. So it's not like it's impossible. I think that our politics are actually causing a lot of log jams that otherwise government would be very much the right one to solve, and we're not solving it. So then it comes to individuals and some horrible collective action problem to solve, and we're not. I think that's my analysis of the current situation, at least.
Other questions, actually, folks? Okay, there's one on the way back there. Can you run it up to him?
Yeah.
No, it's all good. Good questions. Those are good.
Yeah,
I was
totally.
they're on my list too.
Hi, I'm Jabril Ben-Sidrin, and part of my activities is teaching innovation and entrepreneurship at NYU at the engineering school.
Nice.
I took my students to the new lab. I don't know if you're familiar with it.
I've definitely been. Almost moved a company there, yeah.
It's an amazing space for those who haven't seen it. So you touched on this a little bit, but the reshoring and I see what you're doing as potentially a chance to bring back, or not necessarily bring back, but just reinvent or invent new ways of productions here in the US and maybe even in an urban environment. Could you elaborate? Do you see that happen? And what would be the role of your company today, the current one or the future ones,
Sure.
In that? And would you see yourself as potentially really developing the new production tool and taking over little by little, what you said, the production of cars or whatever it is, or the building equipment away from the big players, or providing them with the technologies, the production technologies that would help them innovate?
Yeah, awesome. Great questions. Let me see if I can remember them all. So one of them was a question about reshoring. And so I think that one of the core reason to reshore from my point of view is that the tacit information of manufacturing is often lost overseas. So all the good people who outsource, like if you're an Apple and you're in hardware, unfortunately you just live on a plane going back and forth to your production facilities, because you really should be on the ground tweaking every little thing to make sure quality is good, and they maintain and capture that knowledge. So I remember talking to the CTO of Boeing before and about the really late 787 disaster in sourcing from I think 700 different vendors. All this stuff, and it was this horrible nightmare. And they were not able to make an integrated system very quickly because of that supplier leak. So the question is, we're fully, the Model T was made in a facility that took in iron ore, latex, and silica and produced a car. That was a Rouge River plant in 1913. It's crazy that they built that. And so, obviously that's a little bit too much, although Hyundai actually just did that. They bought a steel mill a few years ago to make specific steel for just their cars. So that actually still happens. Which is really interesting. But I would say that I care about it for the tacit knowledge, and I think that's not going to go away anytime soon. And that, to your question, is that knowledge is in their heads, and that's why they're not going away and why we need to maintain these people who are, machinists are basically like computer programmers. It's the same thing. It's like a very deep knowledge base of an engineering skill. As far as urban manufacturing, I would think more about urban prototyping more. For certain products, I'm sure it can be fine, but I care a lot about how can innovation be very quick. And so, creatives want to live in cities. That's just what it is. So, it might cost, and this is why we thought about moving a Plethora location to New Lab, which I know David Bell, who runs that. And so, he was like, bring a Plethora to New Lab. We just couldn't make it work at first just because we were so concentrated scaling, not because we didn't think it was a good idea. And, it's basically like, is there a local design base who would buy enough parts to do it? And what's the minimum viable scale? And it seems like it could work, I think it was more of an operational question for us than an economics question of why we didn't do it. And then your last question, I'm sorry, was where we put the technology at? Right. And yeah, we don't really talk a lot publicly about that, so I won't fully talk about it. But you're right, there's many ways of doing it, but you have to prove the full stack model first before you start productizing it, right? And so you have to have a factory that actually works. And so that one of the reasons, all the investors wanted me to make a piece of software and sell it to machine shops. And I was like, well, my previous company, I did that, and they don't buy anything because the guys don't like software. They're mechanical guys, they don't like software. And so no one cared. And so, so then I was like, well, you're never going to sell it, so I need to be very vertical to do so. And so that's why I chose that way. But once the technology is mature, you could totally do that. And why blow a bunch of CapEx if you don't have to, if you can partner with someone and take royalties? That sounds like a good deal to me.
Fascinating. Other questions? Here's a question in the front here. Sam's doing a good job moving around. Could you stand up and introduce yourself?
I'm Rahul. I run an artificial intelligence company. My question has nothing to do with AI. It's more about diversified risk. So we talk about vertically integrated manufacturing and the pros of hey, we can use software to build these vertically integrated manufacturing. But the problem comes in with waxing and waning demand. Yes. And so if you have a large company that does similar to what Ford Model T does, you take in steel and all of these components and does everything. The problem becomes the moment we have suppliers, we can diversify that risk, right?
Yep,
so that's one of the reasons why automotive companies, Boeing, General Electric, all of them have these diversified supply chain. So how can we do that using technology introducing software into manufacturing or additive manufacturing? How can we diversify the risk?
Yeah, so you're right. This is, I mentioned Kosa's theory of the firm. That's the exact thing, right? Is the question of is it better to go outside? And it's about transaction costs, if you remember. So the, it's a case-by-case basis, right? Hyundai buying a steel mill was well, they thought they could, and they're probably also running it as a production steel mill for other operations. So they were kind of their own supplier in a sense. But you're right, that often having these internal people without competition is often kind of a bad management exercise, And so what we've seen in like data centers is that people often have hybrids of them, right? So you have the giant AWS iron that sits out as a giant thing producing all the time, and that's sort of what Plethora is in a sense. So also CapEx in this is not actually that expensive. So one of the reasons why steel mills are not great investments to hold is they don't have very good return on capital, basically. They're very inefficient in a money sense, where Plethora is extremely high ROI in that sense. So, so that's part of it. Same for servers, right? It's like the iron isn't the thing, it's the electricity is the thing. And so that's part of it, but it's a case-by-case basis. You have to make a business case for it. I'm not a fan of black and white stuff. It's like you just have to figure out what it is. I assume that the increased automation and ability to flip over those switching costs allow you to just batch process, and that does give you some, like the centralization matters, like Amazon, right? So you end up getting centralization where that is possible to switch over and economies of scale take over. But it's a question-by-question basis, really.
Okay, we got one right here. You can pass right here. You stand up there.
Michael Smolens of .summon and a technology platform with video and language. So if we assume that the exponential scaling of hardware, and I for 32 years of my life, I built factories all over the world making things with thousands of people.
Awesome.
Okay, so I have that.
Previous company you're talking about, right?
Previous companies, yes. If that happens and you build new companies that scale like a Facebook or like an Amazon or like these big companies that have unintended consequences as a result of scale, do you think that the same kind of problem is are you going to develop Cambridge Analyticas in the world who are taking advantage of all of these things? But so instead of you developing the huge things of social media with 2.5 billion people from Facebook, you're making things for 2 billion people that they need to eat or sleep, and then you're going to have the same kind. So what can be done in advance to learn from these mistakes while you're going forward? Because you probably you're going to be the 27th candidate for president. It sounds like you're wanting to be in politics. So if you're going to be advising, I know, I'm just joking. So what would you suggest to do from a political point of view to avoid these kind of problems?
Yeah, I mean, it's funny. I mean, at first I think of like with great power comes great responsibility, right? I mean, so part of this is whenever I used to run an event, it still goes on, about 7 years, it's called the Hardware Startup Meetup. There's actually one here as well. And I would see all these companies that I was basically like, this is probably just gonna be landfill in a year. And that sucks. Because like when you make a mistake in software, you shut the servers off, they do something else. You make a mistake in hardware, it gets buried in a landfill, and that sucks. So that's the first thing, you just waste for making this very easy. Two, a thing we thought about is like, I don't know what every weapon part looks like. So there's like no possible way for me to check if you're making whatever through Plethora, right? We do our best, but like in our TOS says you can't do it, but you could totally have stuff like that. There's the 3D printed gun guy, now in prison, but famously tried to make that more accessible, and that's totally a thing that they could do. So these are certainly things. I think that in the biological sphere, I fear more. The ability now, I have a lot of friends who have biotech equivalents of Plethora, and you can just give them DNA or RNA code and get back a CRISPR vial, and you can put it into E. coli and then amplify it, and I mean, just this whole thing. So in biology is really interesting in comparison. I don't know, I think that from a manufacturing point of view, I don't think about like weapons aside, I think that like it's already, there are factories that have big outputs, that have these effects, like, someone sprayed the wrong thing on, romaine in Arizona, and suddenly half the country's sick and can't have salads. Like that stuff already happens. I mean, I'm a fan of regulation as long as it's agile. I really think that if I'm talking about political solutions, there's this boundary between the legislative and the executive, right? And there's executive law and there's regulatory rules. And so the bureaucracy is tasked with figuring out what's going on in the environment quicker than the legislature. I mean, normally the legislature should be quicker than it is, right? So we're bad at that. But even if the legislature is good, it's going to take them a while to address all the policies. So our bureaucracy has to be very effective. And I think a lot of people right now are like, is democracy okay with populism? Do we have to reform democracy? And and we do. There's obviously, we don't want to have people getting bribed or whatever, whatever's going on now, all the craziness. But we have to solve that. But it's actually further than that. People don't talk enough about good bureaucracy. It's become like a swear word or whatever. But there's been these periods of renewal in America where we got better stuff, right? So in the 1880s and 90s, with like all the oil barons and whatnot and steel barons, the halls of Congress were lined with vaults full of cash, literally, as they were taking bribes, basically. And then we reformed that with Roosevelt and everything else, and then we had an actual good bureaucracy. And then after World War II, again, we had a flourishing of good bureaucracy in the 60s, or in the 50s and 60s. That built out so much of the infrastructure of America as well. I really want another one of those. Is it a Green New Deal, or who knows? But I do think we need bureaucratic reform to make effective bureaucracy. It needs to be cool, and you need to have a good salary when you go into bureaucracies. At least for me, I look at that as like the government is tasked with this. There is an FDA to prevent the romaine from having E. coli on it. I think that's good, but I think that like laws will never be fast enough. Good bureaucrats can be hopefully close behind. That's, I guess, the closest answer I can give you.
Interesting. Other questions of folks here? If not, I'm going to slip one in here while you're thinking about one. There's so many things in your talk we could run off on, but one of the things I was curious about, and we also chatted earlier about it, was the effect of the legacy companies and the kind of baked-in systems, like CAD code from the 70s is still, no one can get off it. How do we deal with this? Or what do you think? I mean, is it the kind of thing, I mean, back in the digital environment, you can just blow up the system and, do an alternative. But do you feel that you can do that? Like, we can't really blow up making a plane, right? But somehow, how do you, because, they'll fall out of the sky maybe or something, right? So I'm just wondering, how do you deal with this inertia in the system in a time when you need a fundamental reinvention to go forward?
In some ways, what's interesting is that, like, people think that, like, the 70s or 80s is when, like, manufacturing got digital and there was nothing automated. We were just pounding hammers or something before. And that's not true. You can actually look at the Ford plant in the 20s and 30s, and there were things that looked like robots, except they were driven by cams and linkages, and they were like, these crazy things they made that were nearly as good as the robots, actually. Like, they weren't dumb. They were very smart, and people actually knew how to do calculus to make gears.
But like, people were behind them, you're saying? I mean, it was like a...
No. They fully just worked. You turn the motor on, and the thing would weld the car and come back. Spot welding happened just the same, except it was a non-computerized thing. They used cams, and they used different sort of like analog things to do it. So what ends up happening is that, like the machines we use, a lot of people are like, a lot of VCs are like, there's got to be some new thing that just happened. Why now, right? And they're like, oh, the new machines came out that would be more programmable. You couldn't use old machines. So I was like, nah, I could buy machines from the 70s and actually do the same thing. It's actually not at all different. So I actually think a lot of the old equipment, they make good parts, right? The parts are fine. It's really the programming of those things. So some of them, if they're made from cams, then yeah, maybe we have to put robots in there and that's just the way you have to eat. But most things are actually somewhat computerized now, but it's dumb computing. Luckily though, dumb computing is still computing, and so you can do the same thing we did to it. And also there's actually, talk about opportunity. Like I remember someone at GE being like, I have X, tens of plants that have equipment from like the 50s in it, and they don't even have any sensors in it. No one solved that yet. There's a bunch of companies picking at little bits and pieces of censoring machines for all the internet, or what is it, industrial 4.0 kind of hype going on. And I think that eventually they will do that stuff. So we can retrofit a lot of the hardware because the parts are fine. Also the tooling. So tooling is like a mold or a fixture, something that's like the unique thing to the parts you're making. So you might have a milling machine, but the vise on it might be customized to what you're cutting, for instance. And that is what we automatically make. And it's one little thing that you switch. And they're used to switching that. And lean manufacturing actually is very good at making normal person systems, changing that stuff out in a few minutes. So I think actually it's much more retrofittable. I again say there are not enough people who know the problems working on them. And a lot of the companies are kind of, I don't know, it's so weird to me. It's like you go to a huge multinational and you get this problem, and I'm like, I can go to a Radio Shack if they existed and buy like $200 of stuff and fix this problem. In like a week. Like it's the problem you have is not complicated, Like when we talk about AI, it's like, it doesn't even matter. You can give me like an Altair. Most problems are still Altair, like checkout systems and whatever. It's very low compute, most of it. So the AI is very fancy, but we just need more people applying this stuff to everything. We haven't even got through normal, digital intelligence yet. So I would say more people.
Do you think it's an education thing then? I mean, do you think
I mean, certainly that's got to be.
I mean, you had this unique thing of your grandpa, your dad.
Yeah, exactly.
You were kind of
my
came out
parents
of
are
a
very
working class.
encouraging.
You were a working class kid,
Yeah.
right? And but most, a lot of people who grow up they don't even know what a wrench is, you know, or whatever. I mean, do you think we need to do something about
So,
that?
I mean, this gets to like my broader point, and why I think your questions are so interesting, is that I actually think more and more in our society, like, think about the different shift changes in how civilization happened, right? We talk about the Industrial Revolution that gave us a lot more productivity, right? That was one big thing. When we got industry, what did Prussia do? Prussia was like, we're gonna have public education, public health, and all these different social services, like pensions. They developed these things in like the 1870s, I think, Frederick the Great. So like they made these things because we needed them to train the workers to make the factories go. And so we made new societies. So that was like the beginning of the welfare state. And unions happened because people were oppressed and so on. So these things happen. So the question is like, what are those things now, right? So we know there's issues with like people losing jobs, and I can't hire enough people. There should be a way to go between them, but weirdly, there's a market failure there. So the question is like, how do we solve that market failure? So my theory of what the next 50 years of the economy could be is what I call the empowerment economy. Weirdly, I would say that the biggest unsecuritized asset class is people. And what I mean by that is like investing in people. Now the government ostensibly should do this, right? There should be services, but you know the government has its own pace and cannot quite be as innovative. So I'm interested in, and I collect financial instruments, weirdly. That's like a thing that I do. So I have a big spreadsheet of financial instruments. And there's a new class of financial instruments, yeah, I know, that are basically like, so anyone ever heard of an income share agreement before? Human capital contract. There's a few of these happening. Some schools, like say Lambda School, I think might be the most popular one. Basically, we'll teach you how to code. We'll pay you a stipend. We'll pay you to learn how to code. And then when you get a job, if it makes under a certain amount, you don't pay. You don't pay the loan back. So only until you make, maybe it's like 70 grand or something, or 80 grand. When you make over that, then you start paying a proportion of the loan. And so it's not like a loan and maybe the education sucked and you can't get a job. It's like, no, if the education sucked and you can't get a job, you don't pay for it. So our current college does not work that way. So the income share agreement aligns incentives from the educator, the student, and the financer to do that. So right now I have friends who are working on the data problem of, you know, how do you know who to invest in with which program? Like, is this person a good fit for this welding certificate or whatever? There's no incentive like this. The government's underfunded to do so. I actually don't know if the public sector even has enough money to do so. I think we need the private sector, probably with regulation from the public sector, to actually be able to do so. So for me, I want these income share agreements and similar agreements to have an entire capital market. So I have a talk called the Human Capital Market, which is about how to make that system to do so. Because like imagine this, like, you know, your first education doesn't work. Okay, cool. Let's buy those underrated assets that are like pennies on the dollar, those income share agreements that didn't work, and let's help you get a job, you know, and then I can flip them, you know, just like bonds. Like it would be possible, you know, if we did this. But you need to have humane, like good finance seal of approval on these contracts, obviously, because it could be horrible otherwise. But I do think you can make a system like this. So anyway, that's my future. I think investing in people is the future.
I've heard that you did this at food camp, right?
That's right, yeah.
Right. This is a fascinating thing, and there's actually some investors here. I'm looking at some of them here. You, sorry. In other words, it's a fascinating thing. So in other words, yeah, you'd invest in a person, but you'd reap the benefit over time, and it would be a nice margin over time if they do well.
Yeah.
But just like you write off a lot of these investors write off all kinds of stuff.
You just need actuarial tables. It's a full data problem. Like one of the hypotheses here is that we just couldn't assess these risk tables, right? We just didn't have the knowledge. We weren't measuring enough things. Now the data exists. The IRS knows everything and everything else. So I have friends actually working on this particular problem of like how to get the IRS data and allow us to then, you know, because they know everyone's income, right? So LinkedIn knows everyone's education. So we should be able to figure out what worked from that multivariate data set. And that's a full problem. It's a very huge security risk. So obviously they're dealing with that, and they have to work with it at IRS. And luckily they were in the Obama Treasury Department, and so they're friends with them. But you know, this is a thing that's happening, is people are trying to
and it's a company that's there's invested money in,
that's right.
in these.
Yeah, it's a little startup. Yeah.
I mean, this is one thing, and I love talking to Nick because it opens your mind and all kinds of stuff. But I would say, I think what's interesting, there is this fantastic thing on the hardware, but I think the next 40 years are going to be an insane explosion of innovation, all kinds of stuff, economics. And I mean, this is another way you could invent a whole different way of supporting people, educating people, industrial policy, all the kind of stuff you're kind of flickering at here, which is a good reason why we had him here. And we're kind of in the last few minutes here, folks, because we got a late start on that number thing.
Okay.
So you know, But I want to just, seemed to be one or less, if there are any last couple questions here before we wrap it. So here's a question here, and then there's one there, and then we're going to have to wind it. And then we're going to have, as you know, drinks, food, and
Nice.
you can schmooze around informally.
Hi, I'm Ian. I had a question. I mean, you're talking big. So, like, you're talking about reinventing the way an airplane's made or the Corvette engine is made. What does this mean for people at their home? They're going to be able to say, I don't need a toolbox at home. I need a screwdriver now, and I'll just like, boop, there'll be a screwdriver. A replicator, you know, like a Star Trek style replicator. Not so much in the kitchen, but maybe some more in the engineering department.
Yeah,
you know? How do you see that playing out? How do you see it affecting people in their daily lives?
Yeah, I mean
and tie that actually to the pizza box thing, because I think that's a similar thing. It made it kind of made you think, what's the young, what is that meaning?
Yeah. Yeah, so I mean, it's interesting. So the replicator was such a powerful thing. It was like the flip phone in Star Trek, right? It's like this stuff leaks from fiction into reality. So everyone, that's the first MakerBot, actually the second one, was called the replicator. So people very much want that to be true. I think right now it's definitely not true and probably won't be for a long time if it does. I think that one thing that's interesting is our consumer training. So like, people, so for instance, Nike ID has a shoe customizer thing that can do anything, materials, colors, whatever. And they said like 80% of people just get the standard designs because no one trusts themselves. Like they want, Phil Knight or whatever to tell them what the shoe should look like because they're consumers and they think that someone else knows better. And they probably do, which, what is that? There's a thing that's called what you get is what you deserve. On those interfaces. And so, I think that like that was sort of the design corollary of these WYSIWYG things like, 20 years ago. So I actually think that we are seeing more prosumer stuff and it's letting people do real things better. And yeah, not everything we work on is a plane or a car. There's plenty of like small stuff that's just, I fixed my plumbing using Plethora, which is kind of an extreme application of our technology, but you can do it. I did fix my shower. But yeah,
you designed a part to fix your shower.
Yeah, it was made from plastic, so I just like measured it, catted it, gave it to the guys in the morning, got it in the evening, and then put it on. Yeah, I know, it's pretty crazy. It's when you're right next to it, you can do what you want. Not available to the public, well, without paying a lot of money, but yeah. So yeah, I think that the home thing is really hard. I think it's probably like the pizza guy more. So like for me, Plethora, it's like, and all the ones like us are, big facilities that can rapidly ship you stuff. So if you really needed that custom shower thing, if it was in, say Brooklyn, it could just come here just like, any other courier service if you really needed it. So I think it'll probably be roughly like that once we get to that point. But also the authoring tools, like, are you gonna design the screwdriver? Are you gonna pull it out of a catalog online? But they already have those. There's like a Lowe's here, I'm sure, right? So, why don't you just get some, Postmate or whatever to get it for you, or you can just go to the store. At that point, it's like maybe the catalog item is fine,
Okay, we had a last question here, or I'll have the last question, but go ahead.
I'm just curious, in your industrial policy, there's been some economists that say that the government underprices its investments in industrial technology and maybe even educational institutions as well. Would you think that in the future we might go towards a system, or in a potential future, maybe we might go towards a system where the government shares more of the benefit of what it actually creates, so as a way to fund other things?
Yeah, I love this idea. Yeah.
And how would you implement it? I mean, like, the government, you talked about the Air Force basically generated, they paid for that invention.
Yeah.
But they didn't own it.
Yes.
So, I mean, some sort of revenue sharing between.
So there's been a few models like this. So one, the name, if anyone wants to talk about this, there's actually the lady who made that like a thing recently. Her name is Mariana Mazzucato, I think. Right. And she has a book called The Entrepreneurial State, interesting book.
Which, by the way, we actually had her at the What's Now San Francisco last fall, and you can watch it online from our thing. But anyhow, yeah, she's awesome. But go ahead.
And so, I actually haven't read that book, but it made a lot of impact on the economics world, of that. Weirdly, my first internship was in a patent office at my school, so I've dealt with the horrible Bayh-Dole Act, which is currently how things are funded and licensed out of universities, which has issues about how the royalties work and everything that are very annoying a lot to work with those. So I do think there's new models needed. One of the ones that I have in my list of financial instruments is called I-bonds. And so one thing that happened is, so there's been this concept, before I talk about that, called the social impact bond. And so the idea would be, say you want to develop some, new medicine, and there's all these people who need it, but they don't have any money, but the government's like, we don't want to pay for their healthcare if they get sick, so, Pfizer, you develop the drugs, and then we'll pay you for success, basically. That was the idea. And then there'd be some auditing system to say, okay, they got the right pills and they did work, and there'd be like this little 3-part trade in there. There were issues on the auditing, so they couldn't, that has not caught on as much. The I-bonds have tried to fix that by the government both providing downside risk mitigation in the financial instruments. So like, if it's losing money, they will make the private investors whole. But the private investors kind of get the middle tier of investments, so they get like the first kind of big money out. But then the government gets a piece of that too, and it gets bigger and bigger. So if it's an outsized success, the government actually gets a huge amount of money, like it was a venture capital deal, to do so. So that actually went live, and the I-bond, there's bonds issued in this way. And then what's interesting about these bonds is that it's basically a trust with a board that allocates these funds to eye research in medical school, various research institutions that do this. And so it's a portfolio approach to solving eye-related, hence the name, issues. So there are people come up with new financial instruments, and that's what I look to is like, what are novel ways of clearing markets? And those are instruments. So I actually don't know Mariana's way, but I know she knows more than me, so you probably should just read the book.
She's an Italian economist based in London, but she's frequently in the States, and she's been totally on this idea of how essentially the U.S. government has invested in so many world-transforming things.
Totally, yeah.
Everything from the computer chips and internet and GPS and those, but even just the things that now tech companies are making bazillions on.
Although Amazon uses the highways.
Okay, that's true. Anyhow, and it's really, it was a super generous situation that doesn't have to be that way, and you could restructure that very easily if people just recognized it. And it's a long time coming. Anyhow, we've come to the end of the conversation. Everybody I can just see was kind of wrapped here. No one left. Everyone's fascinated. I think let's give a really great applause to Nick Pinkston. And there is actually more drinks and a little more food. And you can talk to Nick about anything he said, which is basically so many damn things that, who knows? We'll get out here at midnight. Anyhow, thanks again for everyone, and thanks, Nick.
Awesome. Thank you, Peter.